Lucifer, Phosphorus, Ishtar, Morning Star. All of these consonant names refer to the same celestial body, Venus, being the third brightest object in the Earth's sky. This planet has always attracted the attention of researchers. The dense, opaque clouds hiding its surface have long stirred the imagination of observers, making them envision vast oceans or dense jungles inhabited by monsters. The reality turned out to be much more complex and frightening than these naive notions. So what is Venus really hiding from us? Venus is the second planet in our system, 0.72 astronomical units, away from the Sun, with an orbital cycle of about 225 Earth days. Every 584 days, the distance between Venus and our planet decreases to a minimum of about 0.25 astronomical units. It is noteworthy that during this event, the celestial body always faces the Earth with the same side. However, it is still unknown whether this fact is due to the tidal effects of our planet or is a mere coincidence. In many of its physical characteristics, Venus is similar to Earth. Its average radius is 6,052 kilometers, or 95% of Earth's, and its mass is 4.87 times 1,024 kilograms, which corresponds to 82% of our planet's mass. Venus completes a full rotation around its axis in about 243 days, with its axial tilt inclined at an angle of 3.4 to the plane of the ecliptic. For a long time, Venus hid its true appearance from researchers behind a dense atmosphere and thick clouds. This led to the emergence of the most fantastic hypotheses and assumptions, some of which placed a highly developed civilization under the planet's opaque veil, while others painted a world filled with bizarre life. The development of spaceflight and radar technology allowed for a huge leap in studying Venus. It turned out that radio waves of a certain range freely pass through the planet's gaseous envelope, reflecting off solid rock. Due to this effect, as far back as 1978, the spacecraft Pioneer Venus 1 compiled the first maps of Venus. These data were later supplemented by Soviet automatic stations, though the accuracy of the obtained schemes did not exceed 1 to 2 kilometers and allowed for the detection of only the largest terrain forms. Therefore, the research apparatus Magellan was sent to the celestial body, representing a large specialized radar. Between 1990 and 1994, it transmitted images of 98% of the planet's surface to Earth, with a resolution of about 120 meters. The information obtained by Magellan is still considered the most complete and accurate data on Venus terrain. Before discussing the planet's surface, it is essential to understand its internal structure. According to the most reliable and detailed theory, Venus has a metallic core at its center, whose mass constitutes about 25% of the celestial body's total mass. Observations show that the planet does not have its own magnetic field, suggesting its core is likely in a solid state. This core is surrounded by a molten silicate mantle about 3,000 kilometers deep, with its upper part forming a solid crust averaging about 16 kilometers thick. Due to the high temperature and viscosity of the rocks, Venus' lithosphere does not form tectonic plates, resulting in geological activity that is significantly different from Earth's. Furthermore, the surface of this celestial object has relatively few large impact craters. Vast areas are occupied by basalt plains formed by solidified lava. Some terrain forms discovered on Venus are unique and not found on any other planet in the solar system. For example, tesserae are heavily fractured mountainous regions, somewhat resembling tiles. Other unique terrain forms include arachnoids and circular or oval structures with diameters reaching hundreds of kilometers. Externally, they resemble impact craters, but, unlike them, are a result of tectonic processes rather than cosmic impacts. Even on preliminary processed photos of Venus, it is quite difficult for an unprepared viewer to notice any features of its terrain. Therefore, let's use a topographical map of the planet's surface, where areas of different levels are highlighted in contrasting colors. First of all, the largest elevated region of Venus catches the eye, named Aphrodite Terra. This area can be considered the planet's conditional continent. Aphrodite Terra is a giant territory stretching along the celestial body's equator with extremely complex mountainous terrain. According to various estimates, its length is up to 18,000 kilometers, and its width is about 5,000 kilometers. Depending on the method of defining the continent's boundaries, its area is estimated to be between 29 and 41 million square kilometers, comparable to the size of Asia. Moving over Aphrodite Terra, three vast areas can be distinguished: Tatla, Thetis, and Ovda. The first of these is located in the eastern part of the continent and is notable for housing Venus' highest volcano, named Mothmans. The distance from its base to the summit is about 5 kilometers, and the mountain's total height above the celestial body's average surface level is estimated to be between 8.3 and 8.8 kilometers. Currently, the volcano is inactive, but there is evidence that it erupted relatively recently in geological terms. This is indicated by both clearly defined solidified lava flows and the absence of impact craters on the volcano's slopes. In the western part of Aphrodite Terra lies the Ovda region, an extremely interesting area in terms of tectonic processes. Its mountain ranges are oriented in different directions, indicating the influence of several deforming forces. Additionally, deep fissures with traces of lava flow have been discovered here, potentially representing the planet's most unusual volcanoes. Traveling further west, to the edge of the continent, we can find the presumed landing sites of 4 probes from the Venera series, 2 of which were destroyed by the planet's atmosphere before reaching its surface. All these locations are in the southern part of a vast lowland named Guinevere Planitia. This area stretches for many thousands of kilometers, rivaling the size of Aphrodite Terra. Despite being called a plain, its terrain is a complex combination of various geological formations. It is believed that tectonic forces compressed the planet's crust over hundreds of millions of years, forming ridges and folds. Simultaneously, lava erupted from fissures, filling lowlands with smooth basalt plains. As a result, this region is abundant with both relatively flat areas and well-marked elevations. Guinevere Planitia borders the so-called Beta Regio. In images, this extensive area appears very bright, becoming one of the first terrain features of the planet to receive its own name. Beta Regio is an elevated region of roughly circular shape, about 2,500 kilometers in diameter. In its eastern part lie the remnants of the Venera 9 and Venera 10 probes, which in 1975 gave us the first photographs of the planet's surface. Additionally, they measured the atmosphere's parameters and the soil composition, which turned out to be similar to Earth's basalts. Based on this data, it is assumed that Beta Regio is Venus' largest volcanic massif, making it a prime candidate for finding active volcanoes. Our journey continues north to the second largest conditional continent on Venus, named Ishtar Terra. From west to east, it stretches about 8,000 kilometers, and from north to south, around 2,500 kilometers. The region's area is approximately 8.5 million square kilometers, making Ishtar Terra slightly larger than Australia. At its center lies Venus' highest mountain system, the Maxwell Montes. They rise 11 kilometers above the planet's average level and 7 kilometers above the surrounding area. The highest central part of this region is a relatively flat plateau roughly 400 by 200 kilometers in size. The altitude difference on this plateau does not exceed 1.5 kilometers, making it difficult to distinguish individual peaks due to the low measurement accuracy. Notably, the Maxwell Montes are the planet's coldest regions. The temperature here is about 380 degrees Celsius, and the atmosphere is approximately half as dense as at the surface, yet still 44 times denser than Earth's. Additionally, this region appears very bright in images, suggesting the summit and slopes are likely covered with a substance that reflects radio waves well. It is hypothesized that this could be compounds of various metals with sulfur impurities, such as peridot or galena. These substances can evaporate from lowlands under high temperature, then settle in cooler mountainous regions as fine grains, similar to snow. Studying Venus' surface, one cannot help but wonder, will all these amazing and mysterious places remain unconquered by humans? Is there a chance that someday we will leave a mark on this planet, so close yet so inhospitable? The atmospheric pressure on Venus is about 93 times that of Earth, and the temperature near the planet's surface averages 737 K for 164 degrees Celsius. Such extreme conditions make it difficult for even automated probes designed specifically for Venus to last more than an hour. The idea of terraforming the planet seems like pure fantasy. On the other hand, there are layers in Venus' atmosphere where temperature and pressure are similar to those on Earth. In the last century, ideas were proposed about creating a habitable base floating in Venus' gaseous atmosphere on special aerostats. However, the practical feasibility of such projects remains questionable. Nevertheless, Venus still awaits its heroes, and sooner or later, its secrets will be revealed. Friends, of course, it is impossible to cover such a global topic in detail within one episode. Many fascinating facts have been left out. If you would like to know more about them, please write in the comments. Support us with a like if you enjoyed this video, and see you next time. What technologies do you think could help humanity explore Venus in more detail in the future? Could terraforming Venus become a reality, and what steps would need to be taken for this? What is your opinion on the possibility of creating a habitable base in Venus' atmosphere?